Look at these three dolls, number 1, 2, 3. So this third one is made up of paper. Now I am going to push this first one. Look at it falls down, and second one it also look at how it falls down. Now I am going to take this third one. So now I am going to pull it like this. Look here, it comes back. Look here, when it is made horizontal, it comes vertical and oscillates. So even if it is pushed forward, it comes back, and look here how it oscillates, how it rolls. So look here, of course this type of action you might have seen in some videos in WhatsApp and Facebook. Look here, it is made horizontal. Even it is made horizontal, it is not falling down, it is not lying on the ground. So now look how it acts. Why this is oscillating? So that we have to discuss by using laws of physics. And now I am going to explain how it is constructed. Look here, so this is the doll made up of paper, so that its weight is very very small, very light. It is very light, and inside the ball some mass is filled, clay is filled. The top portion is removed, top portion of the plastic ball is removed, and clay is filled. So this is how this doll is prepared. So the thing is, why it does not fall down, why it oscillates? So that I am going to explain by using animations and also by knowing some principles. I am Pavagada Manjunath, lecturer in physics. In this video clip, I am going to explain why the doll, even when it is made horizontal, it comes vertical. That I am going to explain by using a simple device, by using this piece of wood and also by animation. Now I am going to take a wooden piece. For this wooden piece, another wooden piece is fixed perpendicularly, of course this one. And look here, this is the base. And now look here, there is a point about which I can balance this wooden piece like this. So this point from which we can balance is known as center of gravity or center of mass. Now I am going to fix a nail to this center of gravity. For firm fixing, I am going to hammer it like this, and now this wooden piece and the system is placed on the table. Look here, this is the thread. One end is tied to the nail and there is a loop at the other end, and this is going to be hanged to this nail. This loop is always vertical, and of course this is also called plumb line. So now I am going to take a clip. Look here, this one, the slope, and this wooden piece is made slant like this. Look here, this line is within the base of this wooden piece like this, therefore it is not falling down. Even little more slanted. Now also this nail is within the edge, so it is not falling down. Now little more slanted. Now this nail is away from the edge. If I let it, it falls down. Now the condition is, if the line is away from the base, it falls down. Let me see it once again. Look here, the nail is within the base, not falling down, and again for this position also nail is within the base for not falling down. A little bit away, now this wooden piece falls down. So this is the condition. By using this condition, by knowing this condition, we can explain why the leaning Pisa tower is not falling down. Now by using this animation, I am going to explain the principle of falling of this wooden piece. Look here, this is the wooden piece, and of course this is center of gravity of this wooden piece, and here this is the base. Let us consider a line. Look here, this is the line passing through this center of gravity, and it is vertical. This line is called plumb line. Consider a slope. It is like this. It is inserted here. When it is inserted little more, look here, now this is leaning. This wooden piece is leaning, and look here, this line, plumb line, is within this base. So now this is not falling down. Let me insert it little more. It becomes more slant. Now also it is not falling down, because so this plumb line is within this base like this. So now let it be inserted little more like this. Now look here, it is away from this base. Now it falls down like this. So from this we can understand the principle of falling. In this animation, I am going to explain how this doll rolls. Consider a ball. This is the hollow plastic ball. The top portion is removed, and it is filled with some mass, say, let us say clay, like this. For this ball, now this is the center of mass. For this ball, a lightweight doll, look here, lightweighted doll is fixed. When this ball is pulled one side, so it rolls back like this, and it rolls to the other end like this, and here it is horizontal here. Again it comes vertical, and again it is horizontal. So this oscillation will be going on. So here the question is, even when this doll is made horizontal like this at this position, why it is not falling down? That I am going to discuss using animation. Look here at this position. So this is the center of mass, and look here, this is the base. This outline is the base. The wall of the ball is the base. Let us draw a vertical line from this center of mass, and this is the plumb line. Look here, this plumb line is within this base. So what is the condition for falling down? This plumb line must go away from the base. But even for horizontal position of this doll, this plumb line cannot go away from the base, therefore it cannot fall down. But why it tries to come back, come vertical? Let me discuss it. Look here, this is the center of mass. From the center of mass, weight acts. Look here, this is the weight, that is center of gravity. This from this center of gravity, weight is acting. This is nothing but the force, downward force. Because of the weight of this entire system, at point of contact, there is a reactional force from the ground. So this reactional force is like this, the upward direction. This is the reaction. These two forces are equal, opposite, and parallel to each other. They constitute a couple. This couple produces a torque. So this torque is in clockwise direction. So this torque makes this ball to move towards the vertical position. And at the other side also, the torque is produced. The torque makes the ball to move in clockwise direction. Like this ball will be oscillating. Of course, this is the car, and of course this center of mass of the car, and this is the vertical line drawn from center of mass or center of gravity. These two are the wheels. So here, by knowing condition for falling down and also idea of the center of mass, we can explain why height of the wheels of the car are very small. Look here, they are very small. So now let us introduce this slope like this, so that one edge or one wheel of the car is raised over the other wheel. Look here, even for 40 to 50 degree, the vertical line passing through the center of mass or center of gravity is within this base. As it is within this base, this car will not fall down or will not skid. Even if increase the angle to the 70 degree, even for 70 50 to 60 to 70 degree, this plumb line is within this base, therefore it is not falling down. So in order to avoid the skidding or falling down, the height of the wheels of the car is made very small. What happens if height of the wheels of the car is made very high? Let us see. Look here, this is the car and these are the two wheels, and of course this is center of mass and this is the plumb line. So now let us rise. Look here, height is height of the wheels. Look at this height, it is very high. Now let us introduce the slope. Look here what is happening. So even for 30 to 40 degree, look here, this line is going away from the wheel. Once it goes away from the wheel, the car will skid, the car will fall down. In order to avoid this type of skidding, the height of the wheels of the car is made very small.